Okay, my friends, today, hi. Are you staying today? No, she's got another class. They would miss her if she weren't there. All right, my friends, we are on page. Actually, you know what I'm going to do? Rather than doing like lessony kind of thing, I'm going to have you do page. Is this thing working? Oh, no, it's not. There we are. Page 29. And the rest of 32. Pages 29 and the rest of 32. I'll put that on the board. Get rid of all this. And I'll come around and give you a hand with it, okay? Page 29 and the rest of 32. There is you. There's something else, and you did it with every single other one you put on that one. Yes. So it is go. Okay, and this is FLUO. Yes. Metals have a low electronegativity. But you don't need to know that because, yeah. Okay? Yeah. Yep. Yeah. Let me run you one. Okay, that's pretty fine. But that's really hard. Okay, so we have not really R, but it's A. So potassium, yeah. I don't know. Anyway, Bjorn's here. When your class starts. Oh, yeah. So, periodic table. You have a periodic, fantastic. Hi. That's okay, no worries. It's all good. Yes. Hi. Yep. So potassium is a non-metal? Yeah. Which one comes first? The metal comes first. Yes. Yeah, beautiful. Okay. Barium. Okay. We're gonna skip that one. Subscripts are the numbers that go at the bottom. Yeah, those guys. So, yeah. Yeah. How many? Oh, yeah. This one, something like, oh, yeah. Okay. Oh, so Mary is not on me. Yeah, all good. It's all good. All right. Yeah. Yes. You know what I should do? I should put the periodic tables. Folks, I'm going to put the periodic tables over on this desk here. Okay, put the blue whoopsie woo. And I think I've thrown things on the ground again, haven't I? Because I'm clever like that. Thank you. Okay, yeah, let's put that farther from the edge. And there you go. How you doing? Let's take a look here. Okay, so this one, you're actually gonna write this one over here. Okay, yeah. And how many ALs do you have? Okay, so it's not gonna be AL3, it's just gonna be ALs. You will, but that's when you are. So ale and then jar with the, yes. Beautiful. Okay. And then this one is correct. You wrote the full first, and we'll check it out. Right one. Beautiful. And then this one, once again, right over there, because this is a different question. Okay. Okay, and now you're going to say, I need a compound made of 3 variants. Yeah. Mm-hmm. That's correct. Yep. I always do that. I didn't go like that, bro. I always do that. Yeah, so so that was Perfect.
Say something. I put this in as soon as it was born.
How many ales?
Okay, you try. Okay.
So maybe next day?
Bro, I started this with my mom. So good. Oh, I can't you with my dress. Okay. We take all things. There's a head. And then we jump into the oh, yeah.
So this will be story of
Yes. No. No. Yes.
Summer. And like she always gets sick. There we go. Oh, my other How many for if they're not oh,
Hi.
Yes. Oh. My dad literally just to like this one is like he's like, oh, okay. I'm like, okay, all my schoolwork.
No, it's like the organ started.
I wanted to get that.
Alrighty, thank you, Miss Sanders. Hi. Alright.
Yes.
I just don't.
That's too.
Well, that's.
Okay, so sub. Yeah, this is why we're doing this.
And no,
You got this.
that would be my ideal.
Now, remembering that the.
I will do
Remember
it.
told me how now.
You know, Yeah.
Oh, yeah.
Welcome back. Movie there, this is there. Oh. Oh. But they still did.
And so I sat down.
So I went, you'll see. For once, I just found my own. In soup, I did a little doodle. Oh, I did it. And I went to math and I just like question.
Yes.
Yeah. I would. Oh, let me shake. It's gonna be. Yeah. No, I. You shouldn't be listening. Yeah. You want to be lying? Of the cycle. You want to end this moment? Infuriated, and I hate it. Right. Yeah. Oh, no. And I can hear. I did. I didn't actually.
Okay, my friends. We're going to step away from ionic compounds for a moment and move into covalent compounds. So this is on page 40. Page 40. All right, friends, what page are we all on? 40, excellent. And we're going to be looking at covalent bonding. All right, so here we go. This is a weird one.
Huh? Huh? Oh.
What do you notice about this noble gas? Adrian? It has a full valence shell. And what does that mean? Yes. It is stable. That means it does not want to form an ion. That means it does not want to react, because things react because they want to fill up their valence shell, but these ones are already full. And I don't have my book, so you guys are going to tell me when to pause and unpause. Okay? No, it's all good. Don't worry. I can kind of guess on this one too, but do let me know if I'm not pausing in the right spot for you. Why is it not unpausing?
Oh.
Okay, so little fluorine comes along and says, hey, do you want to form a bond? And then neon says, no, I have a complete outer electron shell already. Too bad. Stay away. Now, what do you notice is different about how those two fluorine, what did they do with their electrons that's different from ionic bonding? They merged together rather than one of them giving an electron to the other, because fluorine has 7. Yes, this one has 7, that one has 7. If this guy gave 1 to the other, this one would have 6, and that wouldn't be good. But by sharing, they can each complete each other's shells. Okay, so in order to get this kind of stability, atoms come together to achieve the noble gas configuration. And you see how they're all like nice and peaceful now? Everybody's just meditating away, very stable. So this coming together and sharing of the electron pairs, this is not an ionic bond. We have not formed ions. Nobody's lost electrons. Nobody's gained electrons. So it's not an ionic bond. This one is called a covalent bond. The prefix co means together. Okay? So if you are cooperating with someone, you are working together with them. If you are cohabitating with someone, you are living together, cohabiting. So this is a covalent bond. They are together with their valence shells.
Huh? Hmm.
Okay, so did you miss anything there? Do I need to go back at all? We're good? So 2 chlorine atoms come together and share their electrons to form a molecule of chlorine. So you only get molecules when the bonds are covalent, when electrons are shared. Yes, I can go back. This one? Okay, should I just leave this here for a second? Little forward. Huh? So it needs one more electron to attain stability, in other words, to complete its octet. Now, what the heck is this octet? Yes. It's full 8 electrons in the valence shell. So you'll hear that word a lot. A complete octet means it has a complete valence shell, because almost all atoms need 8 electrons to complete their valence shell, except for who? Hydrogen and helium only need 2. Woo! What happened?
Ah.
The weirdest freaking video I've ever seen. But it's the only good one I've found on covalent bonding. Yeah, but let's. Okay, hold on.
It's okay. No, it's fine. I just want to respond to her thing.
Not straight days. This was today.
Okay, I'll let her know. Okay. Just wanted to make sure.
Yep. Okay, so when a single pair of electrons is shared between 2 atoms, the bond is known as a single covalent bond. How many electrons is a pair? 2. So how many electrons are shared in a single covalent bond? 2. Okay. Okay, so a single covalent bond is represented by a dash between the atoms, or a line between the atoms. That's how we show that there is a single covalent bond. Cl dash Cl. Don't ever look for Ci, because 99.9% of the time it's going to be Cl. Only on a very rare occasion will it be Ci. And I can almost guarantee you, if it's Ci, it will be Ci4.
Yeah. Oh. Yay!
Okay, so this is oxygen, who for whatever reason is singing Christmas songs. Okay, how many electrons in the valence? Like I said, I swear to God, weirdest video, but it's the only one I've ever found that really depicts covalent bonding well. So here we are with him wearing like having a little guitar and whatever. Anyway, 6 valence electrons. If you had another oxygen atom, I want you to imagine what you would need to do to complete both their shells. See if you can think about that for a minute. Yes? Yeah, you're going to have to share 2 pairs, 4 electrons altogether. I'm sorry, Adri. I saw that expression on your face, like, what the, and why? Okay, so I don't know how much of this you need. Can you still see it? Yeah, it's gotten a little bit dim. There we go. One year I was doing this and it actually lined up with Christmas and I was like, oh, yay! But, yeah, I don't know. December is almost Christmas. I'll take the month of December. Anything before that, I'm still like in no. Oh, what happened? Wrong button. Okay, now you can't really see the OO because it's being cut off by the little pause, whatever. So down at the very bottom, you represent a double bond with 2 lines. Does that make sense? Yes. I'm going to come closer because I can't hear you. Yes. Yeah. Ooh, really good question. So when an atom bonds, does the pattern of the electrons when they're bonded change? And yes, it does. Okay? So if I had a hydrogen atom and a hydrogen atom, hydrogen, the electron would be like in a spherical shape, okay, a spherical blob. Yes? My other hydrogen atom, the electrons would be in a spherical blob, okay? Spherical blob, spherical blob. When we put them together, there is a blob in between the 2 nuclei, and that's mostly where the electron lives. Okay, so there's 1 electron, 2 electrons. You don't need to know that, but it is interesting. Okay, so we have 2 pairs of electrons is a double covalent bond. So how many electrons are being shared? 2 pairs is 4.
Hmm? Hmm.
Okay, so similarly, nitrogen atoms share a triple covalent bond. To form a molecule of nitrogen. So 3 pairs of electrons, or 6 electrons, forms a triple covalent bond, and we use 3 lines. 1 line represents 2 electrons. No, just a reasonable selection. Yes. No, that when I assign it, I'm like, do a reasonable selection until you feel good about it. Oh, and I guess that's it.
In this video, I'll be going over the definition of covalent bonding, how to identify a covalent bond, and then I'm going to...
Okay, is there anything anyone missed in here that you would like me to go and like fill in the blank somewhere? Yes. Which what? Most of page 41. Let's go do page 41. Okay, so we have here a chlorine. It's 2 atoms bonded together, so it is a chlorine molecule. And we have 1 pair of shared electrons. And if we have 1 pair of shared electrons, that makes a single covalent bond. So we watch the process. 2 chlorine atoms come together, and what do they do with their electrons? They share them. Share their electrons to form a what of chlorine? A molecule. In this way, each atom will have 8 electrons in its valence shell. A full valence shell containing 8 electrons is called a complete octet. As a single pair of electrons is shared between the 2 chlorines, the bond is known as a single covalent bond. A single covalent bond is represented by a single line between the atoms. So in other words, we go here, we draw a single line, and then we draw another C. Ah, there we go. Mhm. Okay, and oxygen has how many electrons in its valence shell? 6. Therefore, how many more does it need? 2 more electrons to complete its octet. So it will share 2 of its electrons with another oxygen atom. Are there any other bits that you need? The very last sentence of page 40, sure thing. It's probably octet, I'm guessing, but let's go take a look. Okay, very last sentence of page 40. Yes, it needs one more electron to attain stability to complete its octet. Okay, yes. Second line, page 42, got it? So when 2 oxygens come together, they each share 2 electrons to complete their octet. The one below it, okay, yeah, I wasn't sure. Since they share 2 pairs of electrons, it's not a single bond anymore, it is a double bond. So we have an O, we have an O, and this is a double covalent bond. Is good? Algo más? Anything else? $43. Okay. Borna? Yep. Okay, page 43, and you wanted, what did you want? Number 6? Like question 6? Oh, well, you got to try them first. Everyone's got to try them, so I'm not going to tell you just yet. Okay, so you guys, you have like what, 5 minutes left? So your homework is to complete page 43, and I'll come talk to you, Olivia, about number 6. Okay, I just don't want to give away the whole game. So your homework is to complete page 43. So not very much again.
Okay, so how many electrons are there in the C and the H? What percentage in the C? That's like, what is
Yeah, so single one with one shared there. One electron.
Oh, yay! I completely blanked on the fact. Oh, my.
Okay.
No, now.
So how many lines are there? Three lines. Four lines, so how many pairs? Three pairs. Four, we're not four lines. Okay, so we one seated two, and that's three. Those are, each line represents a pair of.
I think I'm in this one.
So let's try illustration.
I'm weird, right?
Yeah, perfect.
You? Okay, good, good.
Yeah, one thing. Yeah.
My favorite things.
One thing.
Yes.
And she got deep information that I got. So, sounds like, so you would, if you have to it here, you have to go on there, okay, right? So you could be like, okay, so. Yeah. Yeah. So you'd be like, okay, what do you do in H2O? Yep. I don't know. Yeah.
Hi, I finished the homework. Can I leave a little bit early? I need to grab something from the library.
For sure, yeah.
Thank you.
In the hall. That's